So good morning, sir. Krishna, sir. Sir, can I start? Shall I start, sir?
Yes, you can start, sir.
Yes, sir. Sir, good morning to all the attendees for the session on online short-term course on advanced simulation tools for power electronics, electromagnetics, and power systems. Today is day 3. We will be dealing on the electromagnetics. In the last 2 days, we saw the power electronics applications in the real-time scenario using PSIM software, and today we will be seeing the JMAG software, where the electromechanical machines, all the machines, induction motors, whatever, all those machines, how they are being designed using the software, and how they are being deployed into the real time, and how the efficiency of them will be affected if they are not properly designed. So that is what the main agenda of the today's session. So having said that, I will be handing over the session to I welcome Joseph sir and Sadeep sir for take over the session, sir. Thank you.
Yeah. Thank you so much for the introduction, sir. So I think we are ready to go, right? Yeah.
Yes, sir. Yes, sir.
Okay.
Yes. So one thing, this is pure theory part. Today we are going to show you. No need of any software to download. So we will show you how the software works and how it can be done in the online tool. So we have an online platform where you can work out. So Sadeep and Joseph will show you the entire details. So kindly be patient. So don't interrupt in between. So if you have any queries, reply them in the chat window. So our people will answer you in that particular. So thank you one and all. Yes, Sadeep, good to go.
Yeah. Thank you, sure. Thank you. So good morning, all. This is Sadeep from JMAG team, and I welcome you all for this session on JMAG, which is used for the design of electromechanical devices. And today we will be focusing entirely on the machine side. So hence the topic, the JMAG for design of energy efficient motors. So hopefully you had a good session for the last 2 days with the power electronics PSIM software as well as the power system EMTP softwares. I hope you have learned a lot regarding those two software. So similarly, I'll try to give you an introduction on JMAG. So this session will be lasting for 1.5 hours. So we have split it into 2 parts. So myself, I'll be taking the introduction for the presentation of JMAG, and the introduction to the GUI of JMAG will be done by Mr. Joseph. So without further ado, let me start my presentation. So if you have any queries regarding this, kindly use the chat window. You can list your queries down there with your email ID so that we can connect back to you after the session has over. Okay, so I'll start the presentation. So if you can see, JMAG is a finite element analysis tool which is used for electromechanical simulation. So with finite element analysis, the understanding is that if you have to solve a complex problem relating to something of like electromagnetics, like if you want to do the structural analysis, if you want to do the magnetic analysis in some particular type of equipments, for example, the machine, if you take such, you can see that the machine as such is a very complex phenomenon. So there are a lot of things happening inside a machine. So if you want to solve the complete model, this finite element analysis will help you to do so with a few approximations. So finite element analysis is usually breaking down the complex module into a simpler model and formulating equations for each simple model that we have generated, and it is known as the mesh elements. So with that, you can just give the algebraic equations. You can solve the equations. You must have learned something called as the partial differential equations in your tenure. So you can use those, and you can give the output as a finite element analysis equation. So that is what is entirely what it means to deal with the finite element analysis simulation software. So JMAG deals with all these things. So JMAG has an inbuilt solver and inbuilt module for doing all such analysis. And this was developed in the year 1983 by the JSOL Corporation in association with the Japanese Research Institute. And it is comprehensive software package which is used for mainly four purposes. So you have the design validation, optimization, and a coupled electromagnetic, thermal as well as structural session. So with design, right nowadays there is a lot of demand in designing new kind of electric machines, particularly in the field of electric propulsion or electric vehicles. So if you have done a good analytical design with your books or theory practices, you can fetch those details and you can directly provide the details to the software like JMAG. So if you once feed the software with these informations, the software itself converts it into finite element analysis measures, and then it will help you in solving your design problem. And it is also, so if you have a new design, you can do the validation, and also there is an optimization engine that is being run inside the JMAG tool. So with optimization, what it means is that, so suppose you have a design, so and you are getting a result out of it, but you never know that whether it is the best design or not. So optimization helps you to understand whether the design that you have with you is going to be efficient with respect to the parameters or constraints that you have designed. So that is with respect to optimization. And then you have the coupled electromagnetic, thermal, and structural analysis. So JMAG gives you an interface to do all these three types of analysis together under one platform. Okay, so the main markets that we are into currently are the automotive, the electrical machineries, automobiles, and heavy industry sections. Also, we are currently now working with many research institutes across India and across the globe, and we are obtaining some good results out of the research collaborations. And if you see, like I told you, we can design any type of electromechanical components using JMAG. So if you see, we can do the motors, alternators, transformers, switch gears, solenoids, as well as the reactors. And particularly today's focus, we will be doing entirely on the motoring part. So if I go forward, so like I told you, JMAG is a finite element tool which is used to solve the complex problems in a very cost critical way. So if you see, suppose if you have a design, if you have a motor design, so instead of going or using a simulation, if you directly go for the prototype manufacturing, then the problem comes. See, the prototype that you may create through your analytical method may not work. So you will be needing to make n number of prototypes to arrive at the best optimum solution. So if you have a simulation platform like JMAG, you can directly feed in your design details, and then you can assess whether the design that you have done, whether the performance that you are getting out of the simulation is matching your design. So this is what is about the introduction of JMAG. So now if I go to the module sections, so JMAG basically comes with three types of modules. So the one is the first one, the JMAG Express module. The second one is the JMAG Designer module, and the third one you have the JMAG RT module. So Express Plus module is like I told you. Express module asks you for certain inputs, like you have to input your machine details, you have to input what type of materials you are using for the simulation, and what type of drive you are going to configure. So all such things can be done using the JMAG Express module, and Express is the most basic module we have in JMAG analysis for 2D analysis. So it's based upon the analytical lump circuit parameters as well as a number of fine meshes that will be generated automatically in Express. Now coming to JMAG Designer, JMAG Designer will give you a detailed FEA analysis. So once you have a model ready in Express, it will be an approximate model. So it will be around 90 to 95 or 80 to 90% efficient based on your design. So if you want to fine tune your module, you can directly import this model that you have done in JMAG Express to the JMAG Designer module, and here it is where you do the finite element analysis. So whatever parameter or constraint that you are focusing on, you can fine mesh that module, and you can see for yourself how much accuracy you are getting out of your simulation in JMAG Designer. And the thirdly, if you see, there is another module called JMAG RT module, which will support you for your real-time control simulation. That means that you can take your JMAG model that you have created using Express or Designer, and you can connect it with a third-party software like MATLAB. So suppose you want to do some advanced control simulation with the real data that is available from the motor, then you can go for the JMAG RT option. So this is the complete product portfolio we have. So if you can see, this JMAG Express is the basic design tool that I have talked about. So here is where you do the initial optimization based upon the your design. Okay, and from here you go to the JMAG Designer. So Designer is the complete FEA model which have the pre-processing, post-processing, and a solver inbuilt for solving your complex FEA problems. Okay, so it also supports optimization, like I told you, parametric optimization. JMAG Express also supports parametric optimization, but with some restrictions. But Designer, you have a full-fledged parametric optimization available. You can write down your equations and whatever not. You can do the scripting using Visual Basic. You can use Python, and you can script your own code here. And once you are ready with this, you can import your model using JMAG RT, the third one, like I told you. And in JMAG RT, you can co-simulate your model, whether it is a software in loop simulation or hardware in loop simulation. It will support these many sub options available. So you can co-simulate it with MATLAB, PSIM. You can co-simulate it with OpenRT, DSpace. So these are some of the commonly available tools that you find in every colleges or universities. And like I told you, there is another option. So JMAG Express has a number of inbuilt templates that is available for you. Like you have different types of motor. So for that, each motor you have different templates available. And also there is an option of importing your own CAD models. So suppose you are well versed in CAD, so you can draw your own stator rotor configuration using CAD softwares like SolidWorks, CATIA, Creo, etc. So you can directly import whatever you have drawn in that CAD software into JMAG Express or Designer, and you can do the analysis. Now, coming to some third-party partner products. So suppose you want to do the cooling or the how the thermal analysis works and how you can reduce the temperature inside your motor module. You can use some of the partner products that we are associated with, like Star CCM Plus. There is some other software like Particle 3D. So all this helps you to understand cooling in a better way with the help of JMAG. And if you see, we also support some of the good cloud systems like Focus, IBM, Fujitsu, etc. to name few. A few more have been added recently, so that is yet to be updated. Now, if I come to JMAG Express, so I told you this is the basic module of JMAG. So when you have a design with you, or suppose you have a motor model with you, you have a motor available in your lab, you can just open the model. I don't know how many of you have done this or not. So that is the basic procedure that we do. You can just open up the model. If you don't have a design ready, you can use a vernier to measure all the machine dimensions of the motor that is available with you, and you can input those specifications here. Like the JMAG Express module will ask you for the geometric specifications, and likewise you can ask the manufacturer for the material data. Sir, what material you have used in this motor model? So he will give you the material data here, and the winding configurations also he will be able to supply you, or else you can find it out with yourself using your lab support. And lastly, you have a drive data. So whatever motor you are using, there will be a drive associated with it. So in Express, what we do is that Express has an inbuilt drive for each motor model that you are using. So for induction motor, it is separate. For permanent magnet motor, it is separate. For switch reluctance motor, it is separate. So if you want to do some changes from the drive point of view, you have to take the model that is run in the Express into the Designer. So Express is the basic template that you have, and if you do the analysis, you will get the result within a click of the second. So likewise, if you see, these are some of the outputs that we focus in JMAG Express. So we have the torque output, speed output, efficiency, power factor, as well as the design side. So that will give you a better understanding about the software and whether your design is suitable for further analysis, or is there some shortcomings in your design. So these parameters will help you guide for you to take your model to the JMAG Designer. Now, if you see, these are some of the motors that can be analyzed using the JMAG Express window. So these are some of the inbuilt templates that is already present in JMAG Express. So you have the permanent magnet motors, like you see the first and second one. You have the interior permanent magnet as well as the surface permanent magnet machine. You have the induction motor, you have a burst motor, switch reluctance motor, universal motor, synchronous machines, to name a few of the templates that you can use within the JMAG Express. And every motor will have its own stator and rotor combination, and that will be like each motor will have some 10 or 15 combinations of stator and rotor available for your analysis. So likewise, in the previous section, I told you like you can either create your own DXF file in some third-party software, or JMAG also has a inbuilt geometry editor window. You can create your DXF file inbuilt in JMAG itself, or some softwares like SolidWorks, as well as you can use the standard templates that is available in JMAG. So if I can show you, this is one of the stator geometry and rotor geometry that was created using the JMAG geometry editor window. So it is like any other CAD software. You need to understand the basics of creating a geometry. So there is a self-learning system available within JMAG for you to do the things from scratch. You can do your stator combination as well as you can do your rotor combination. So this is the first method of using your own DXF file. And the second one, like I told you, the standard template. So JMAG Express comes with the standard template. So if you can see, these many combination of the rotor and these many combination of the stator is available for your model. So you can select any which is of preference for you, and the template will automatically come within the JMAG Express. Now, like I told you, JMAG Express asks you for some of the inputs. So the first input that the Express section asks for you is the geometry details. Likewise, I told you, you can either design your own model with respect to all these parameters. So these are some of the generic parameters that is available within the motor, this permanent magnet motor. So you have to first design based on this, or else if you have a permanent magnet motor and if your guide provides you the provision to open the model, you just open the model, you take down these values and you feed it into JMAG Express. And likewise, I told you, once you are done with the geometry details, you can directly go to the material details, wherein you have to fill in the details like what type of stator material you are using, what type of magnet you are using, the coil material, the rotor core. So all these things can be done using the material data section. Now coming to the third part, the most interesting part, you have the winding data here. So if you see, this JMAG Express has an inbuilt drive and winding configuration within itself. So you can either choose the option of automatic winding or the manual winding. So in this case, we can use the distributed or lap winding section. And if you see the coil resistance, it automatically calculates the resistance of the coil based upon your input. So if you see the input item, there is coil resistance here. So based on that, if you know only the coil resistance, you can directly enter the coil resistance here, and all the other parameters will be automatically taken care of. Likewise, you have number of turns per slot fill factor and wire gauge. All these factors are available here. So based upon your design details, you can fill it over here. And lastly, I told you every motor comes with an inbuilt drive here. So the drive will ask you for some of the factors, like in this case of this permanent magnet machine, it is asking for the DC voltage, rated current, the voltage drop, the slit width between the segments. So all these things will be already ready and available with you for performing the analysis in JMAG Express. So suppose you want to make any changes in the drive section, you have to take your model from the Express to the JMAG designer window, where you can edit your circuit in your choice. So whatever new circuit you have developed, you can do that there. So now if you see, if you have given all these details and if you have pressed the evaluate button, you will get the results within a click of the second. So now if you see, these are some of the results we will look forward to in JMAG Express. You have current, iron loss, power. You can see also the torque, efficiency, copper loss, etc. And here if you see, if you see, from these results, you can, I think there is some disturbance going on. So from these results, you can analyze whether your model is capable of dealing with whatever design you have done. So this is a performance analysis that you are getting out just within a click of a second, you can just understand how much current is flowing, whether my motor is able to withstand this current, how much copper loss is happening, what is the torque that is being produced across the speed curve that you have formulated. So all these things you can get out of JMAG Express within the click of a second. Now that is from the results part. Now if you see, there is another interesting thing with respect to JMAG Express. So once you have done your analysis and once you have evaluated your motor, you can see a design sheet available with you after the analysis. So this design sheet will give you all the parameters that is existing or that has been calculated by JMAG Express using its inbuilt module. And likewise, you can see the equivalent circuit parameters, the electrical parameters, the power, the loss, how much efficiency is provided based upon different parameters like the speed parameter or the torque parameter, whatever input you have given, based on that you will get the output. And similarly, if you see in this side, there is a mass property calculator. So in mass property calculator, you can assess the weight of the motor, how much iron is being used in the motor, how much coil is used in the motor based upon your inputs. So you have given some input in the copper section, like I am using this much copper, the phase resistance is this much. Based upon that, it will calculate the coil mass, the stator magnet mass, the total weight that is available. And from this mass property table, it is easy for you to understand how much cost will be coming about out when you make a prototype, how much amount of iron is required. So you can calculate that based upon your normal values of iron that is available in the market today. So here, this is one of the interesting topic, like normally when we do any design, the weight and the size of the motor is of prime concern. So we have to initially fix this part and then you do go for your design, so that at the end of the result you can assess. So I have designed for 4 kg, so it is coming around 3.8 kg, so my design should be good. And similarly, if you see, there are a number of yellow colored sections available here in the design sheet. So these yellow colored things can be optimized. I told you there is optimization available in the Express and in the designer. So in the Express, for the permanent magnet motor, you can do the optimization for these many things. So by optimization, I mean that suppose you have an outer diameter of a motor to be like I have given here 112. Okay, so for 112 you have fixed the detail and you have got an output for that. Now suppose you feel that no, I need to fine tune the model. I want to see the outer diameter varying between say 110 and 120. So you can directly input. So you can directly input the outer diameter values here, and you can perform the number of decision, and you can get the optimized result out of this Express module. Okay, so this is about the Express module. Like I told you, Express deals with the 2D part, analytical plus FEA, and it is an inbuilt module with the inbuilt templates. So now if I come to the next section, designer, where you actually do the finite element analysis, you can see that there is two options in designer. So one option is that you can directly import your model from the Express file you have created. You have run a model, you have evaluated a model. Now if you want to directly see the finite element analysis and you have to solve the problem directly, you can directly import this Express file that you have created. So that can be one input for your JMAG designer. The second input for a JMAG designer is that you can directly create a CAD model in JMAG or in a third-party software, and you can bring it here. And with that, what you have to do is that, again, like you did in Express, if you have a new model that you have to directly see in designer, you have to provide these details to the designer, like what type of material you are going to use in designer, what is the FEM coil and the circuit you are going to use, the power supply, the boundary condition. So boundary condition is an important factor in finite element analysis for any type of application, because it is processed with respect to a boundary, the finite element analysis problem is solved. And similarly, the meshing, how you want to mesh the model. So there are many options, what type of parameters you want to focus on more. So that will be given a better weightage, and you can create thin meshes so that the solution or the accuracy of the model will be higher. So this is about the input part with respect to the JMAG designer module. And if you can see in JMAG designer, like there are number of analysis that is possible in JMAG. So if it is a 2D analysis, so you have these type of analysis that is available. You can do the static analysis, transient analysis, the frequency type of analysis, and the axisymmetric analysis. So if you see, if you perform any type of these analysis, now you can see these are the outputs. Previously we were looking into torque, efficiency, etc. So here you can see the magnetic flux distribution, you can see the magnetic field strength, the heat flux, the heat density, the electrical power, see the eddy currents, the inductance, the harmonics. You can do the FFT analysis on that. So designer is a very wide spectrum when compared to the express. Express is the basic module, you do the FEA in designer. So likewise, you have seen that we can do the inbuilt CAD modeling in the Express. So likewise, you have a designer module where you can do the 2D as well as the 3D model within the JMAG software. So there is a self-learning system. You can access the self-learning system. It will guide you how to create your model from 2D from scratch, how to create the stator, rotor, etc., and import it into JMAG designer. So previously I told you in Express there is an inbuilt drive circuit, and if you want to modify any inbuilt drive circuit, you have to bring it to the JMAG designer window. So if you see, this is the JMAG designer window for the circuit editor. So there are number of tools that is available that will be shown by Mr. Joseph. So if you see the power supply, the connections, the star connection, how much is the number of winding, how much is the winding resistance, the combination of the windings, you can all fluctuate everything in the designer module. You can create your own circuit and you can fit it into your motor. So that is also possible in the circuit editor. Now, if you see, this is the complete essence of the finite element analysis simulation. You can see a number of triangular shaped elements that has been formulated. So these elements are, like I told you, you are splitting down a complex model into n number of small meshes. So this one triangular mesh will be solved using its partial differential equation. And likewise, you can see that some of the meshes are very thin and some are very large. So that is depending upon your accuracy. So where you want to get more accuracy, you will be fine meshing it, or you will be thinning the mesh. So if you see across the tooth, this is where the magnetic flux lines flow from the stator to the rotor or vice versa. So this is the point of interest in most of the finite element analysis simulation software. So these areas will be meshed in a very thin manner. Okay, so if you go to the core back width, etc., the number of meshes will be lesser and it will be wider. So because we don't want much accuracy in here. So if you want to do a model with complete accuracy, you can thin mesh every part. Okay, so if you see, JMAG supports one of the most important features in JMAG is that it will support automatic meshing. So even if you don't have any much idea about finite element analysis, you can come up with a meshed model. So if you have much details about the finite element analysis, so you can go for different options of mesh that is available. You have slide mesh, you have extruded mesh, you have some meshing like layered mesh, skin depth mesh. So different combinations are available. So for initial practice purpose, you can always go with the automatic mesh option that is available with the JMAG. So based upon your inputs, JMAG will automatically assume that you want to mesh the model in this way. And like I told you, in the normal purpose, this tooth area is where the meshing is done in a very most thin manner. So it will automatically set it in that way. So if you see, we have seen some graphs in JMAG Express like torque, efficiency, etc. So if you see, magnetic analysis of a motor using JMAG Designer will give you such type of results. You will be able to see the magnetic flux density, how flux is varying from different parts of the motor. So if you can see here, approximately it is coming around 0.27 Tesla. So if you go here in this side of the section or inside this module, you can see some sections which will give you up to 2 Tesla. So you can understand how much amount of flux is being linked within inside the motor, and you can analyze whether your motor is performing good or not. Okay. So similarly, you can see the magnetic flux lines, how the flux lines are moving from the stator teeth into the core and into the neighboring stator. Similarly, how the magnetic flux is moving from one magnet outside and into the next magnet. So all these things you can see using the magnetic flux line option that is available in JMAG Designer. And similarly, you have some of another important functions, like you can see the iron loss density, you can see the eddy current loss. So this is an option for seeing the iron loss, how much iron loss is happening. So this will help you, like if more iron loss is happening, you have to change your material or you have to do some changes in your model. And with respect to that, you can see also the circuit current with respect to time, as well as the torque versus revolution speed. You can match all this. You can fix all these values, like you can project this motor revolution in the type of number of cases, like you can take this as a case. So likewise, you can create n number of cases and you can plot your torque for each case with respect to the speed you are using. So this will help you in understanding this certain types of phenomenons, like how much torque ripple is being produced in the motor, how to avoid that, or the clogging torque phenomenon. So all these can be helpful. And this is the current, and like this is the Joule loss density distribution, like I told you, how much loss is happening in the copper loss is happening within the motor. And this is another plot which represents, like the flux lines, you have the vector lines. So how much, how is the vector lines flowing, and where is there any point where the hotspots are being created within the model. And this is another graph which gives you the air gap flux density. Air gap flux density is a very interesting phenomenon when you design any motor, because some amount of flux has to pass between the stator and rotor, and you have to fix that value in order to have a good design. So similarly, we have some other parameters like you find in the permanent magnet motors, finding the LD, LQ inductance, the torque values, how much electromagnetic force is acting on the core. So all these things, you have conditions that are available within the JMAG designer. You can just import the conditions and you can set the condition pertaining to the part of that motor which you are going to use. So like I told you, how the Coggin torque phenomenon happens and how it is changing when the skew is applied. So skew is like you are tilting the stator or rotor configuration. You can do the combinations. You can do different types of combination. Multi-slice function is available within the JMAG designer window. And similarly, like I told you, like Joule loss, you can find the eddy loss, how the nodal force is getting distributed, whether any part is getting infected. So if you see how much force is being distributed at the ends of the stator or the magnet. So these things you can calculate. So these things you can calculate using the JMAG designer window. So likewise, I told you, so Express is the basic thing, and now what you have seen is the designer, where you do the finite element analysis. So whatever we have seen till now is the 2D analysis. So 2D analysis is done for the complete magnetic analysis study. Now if you want to do, so suppose if you want to do a thermal or structural part, then you have to go for the 3D analysis tool. So if I show you, in the designer itself, there is an option for converting the 2D model into 3D model. So this is about the thermal module that we have. So you can do two type of analysis in thermal. One is a steady state analysis. The second one is the transient state analysis. So steady state analysis, you start a motor, you run it for some time, you stop the motor. What is the temperature distribution after you stop the motor, that you will get at the steady state. Similarly, transient state analysis, while the motor is running, you will get the thermal value, how much temperature is increasing, how it is increasing the stator, rotor, etc. You can see using the transient state analysis. So similarly, like you have seen in the 2D analysis, this 3D analysis of a motor using the thermal module will need you to give some inputs into the motor model. Now you have done the 2D analysis, right? So now the next part you have to do is the 3D analysis. So you have to do the 3D magnetic analysis before you go for the 3D thermal module. So from the magnetic analysis, some of the inputs like the Joule loss, the heat loss, etc., you will be finding out using the magnetic analysis itself. So that will come as an input to the thermal module. So if you can see, the thermal module asks for the following input. So some of the inputs include the motor losses, the copper loss, the stator current, rotor core loss, the eddy current loss, the end ring loss, the magnetic loss. So all these losses you can calculate from the 3D magnetic analysis itself. So what additional things you have to put inside the thermal module is the thermal material properties, the thermal circuits, the heat transfer boundary conditions. So every material has a particular thermal property. So you have to find out the value based upon the material you are using, and you have to fill the value inside the column. And you have to draw a thermal circuit for your motor model. Thermal circuit means like how the heat is being moving out from your motor model into the atmosphere. How much heat is being how is flowing from the rotor, how it is flowing through the stator, how it is flowing to the casing, and how it is flowing out of the casing to the air. So that is meant by this thermal circuit. And if you see, the third part is the heat transfer boundary condition. So you have to assess and you have to mark the heat transfer boundary conditions in the motor pertaining or considering the thermal circuit that you have already made. And if you see, like you had outputs in Express, you had outputs in Designer. So now if you come to thermal module, there are certain types of outputs that we focus on, like how much temperature you can find, and how is there any place where hotspot is happening within the motor. And also you can see the heat flux density, something like the magnetic flux density. You can see the heat flux density within the motor. So like I told you, this is a thermal circuit that was generated for the permanent magnet application. So if you see the thermal circuit, you can see how the heat is being transferred from the shaft into the rotor. Then there is an air gap between the rotor and the stator, and the stator there is coils, and the coil between the coil and the cover there is air. So the flow of the heat to the atmosphere, that is what is meant by this thermal circuit and how you model it. You can give some reference temperature value here, and based upon that you can finish your thermal circuit. In most cases the thermal circuit will be similar in most of the motor types. Only few changes will be there here and there. But if you are doing a completely new design, you have to reframe the entire thermal circuit that is available. Okay, so this is about the thermal circuit model. Now, like I told you, based upon the thermal circuit you have provided, you have to fix the heat transfer boundary conditions, like how from the rotor core to air there is some heat transfer occurring. So that condition or that part you have to select and you have to fix it. Similarly, from the rotor core to the air gap, the shaft to the air, the end rings to the air, the stator core to the air, as well as the stator core to the air gap. So these things is what it means in heat transfer boundary conditions. So like I told you, two types of analysis are possible. The first one you see here is the steady state analysis. The second one you see here is the complete complex transit analysis. So steady state analysis give you the temperature once the motor have finished running, and you can see how this temperature is varying in each part of the motor. So somewhere you can see this in this region it is 111 degrees Celsius. If you go further inside, you can see the temperature has increased to 125 degrees Celsius. So this can give you a good understanding about, like if you see in electric vehicle propulsion, for example, the motor design needs a good thermal analysis part. So whenever you design a motor, thermal becomes a very important or core part of the analysis. So if the temperature goes beyond certain values like 120 or 150 degrees Celsius, the motor will operate or fail to operate in a very less time, or the reliability of the motor will be very less in such conditions. So that is where this thermal analysis phenomenon plays an important role in assessing the steady state as well as the transient analysis. So if you see the transient analysis part, you can see the stator core is the part which is getting heated up the least. So second, you can see the rotor core is heated up more, the cage is the more, and the coil is the hottest part out of the lot. So likewise you can see it reflected here. So it is increasing from a temperature of 0 degrees Celsius, and the motor is running, and it is reaching up to 120 degrees Celsius when it finally settles or the motor is stopped or the steady state is being reached here. So this simulation was performed for a time period of say 8,000 seconds. So you can accelerate the simulation based upon certain inbuilt solvers within the JMAG designer. So this is about the thermal analysis part. Now in the 3D, like the thermal, there is another important application that is available, that is called the structural analysis part. So structural analysis is also very important in the case of electrical motors. particularly in the case of some accelerated performance analysis tests, like in the electric propulsion, wherein you can see that when you design a motor and you start running the motor, it will work fine. Say, for example, 2 days, 10 days, 30 days, it's all right. But inbuilt some particular type of structural problems are occurring that you will not be aware of. So this structural module will give an analysis how the stator is getting deformed when you are pushing, or when this type of forces are acting upon the motor, or how the rotor is deforming, how the eccentricity is caused, what type of forces are produced out of the motor, like the radial forces, the tangential forces. All these things can be calculated using the structural module. So if you see the input, the mechanical structural module will ask you for the electric magnetic forces. So you have to apply some magnetic forces that is available in the conditions. So you can directly fix the forces that is getting applied on your motor model, as well as mechanical material property. So you have to fix the material properties of that mechanical part, the friction, all those things, whatever comes in the mechanical section, you have to fix that. And you can do these type of analysis in the structural analysis part. You can do the static analysis part. You can do the eigen mode analysis, the frequency analysis, transient analysis. So everything is a mixture. It's similar, but the analysis is different. So first you have seen the basic 2D magnetic analysis, 3D magnetic analysis, 3D thermal, and now it is the 3D structural analysis. And the outputs that we focus here are the, like I told you, the mode shapes, the stresses that are occurring on the motor, how the shape is getting changed, shape deformation, the acceleration within the motor, how much sound is being produced in the motor. So sometimes you find that in electric vehicles, there is a limit, like only this much amount of sound should be produced when you use this type of motor. So all these things can be dealt with using the structural analysis. Now, if you go further, you can see this structural module simulation. Like I told you, you can see there is a constraint called the all bolting location. So it is bolted from all sides, and a beam is created to represent the rotor part, and load mass of 0.44 kg. You can see a mass of 0.44 kg is applied on the rotor, and based on that, when you apply this force on the rotor mass, how much frequency, how much effect is happening on the motor, that is what we are studying here. When you are pressing the rotor with a mass of 0.44 kg and it is bolted from all locations. So based upon that, you can get a frequency measurement chart, how much force is being produced within the motor. And similarly, if you come to the next section, this is the overall results that we are getting out of the previous study of using a rigid mass on the rotor. So if you can see, I told you different types of stresses, like the centrifugal force, the radial force, etc. So you can see here, centrifugal force, the radial force, etc. plays a very important role in the structural analysis. So if you see, this is our stator. So you can see at 3600 hertz, the shape of the rotor is deforming. The stage of the rotor which you have created is deforming into a different shape. So such type of results can be predicted out of this structural analysis. Okay, so similarly, if you go further, you can see that the sound. This is some of the sound. How much sound is being produced out of the motor? So a noise level at 100 mm away from the surface of the rotor case due to resonance occurs at 3600 hertz. So at the same time, when the stator deforms, there is a increase in the noise level. So such type of studies can be performed using structural analysis, and it will contribute very good in analyzing your motor in a perfect manner. So likewise, I told you, you begin with the design that you have, or you're getting some design, you begin with that, you input it into JMAG Express, you evaluate the model, you get certain torque, efficiency, etc. And once you fix the values, you can directly go to designer, where you do the 2D FEA analysis based upon automatic meshing for the time being. And from there, you convert the model into a 3D model. And in the 3D model, you can do two types of analysis. You can do the thermal analysis, you can do the structural analysis. In thermal, what you do is that you assign the thermal properties of the material, you create your thermal circuit, and you couple the losses that you are obtained from the 3D magnetic analysis into the 3D thermal analysis. So once your thermal analysis is ready, you can go for the structural analysis, wherein you will be developing electromagnetic forces and you will be inputting the mechanical parameters, and based upon that you will be creating a study, and that study will focus upon the deformations, the noise levels, the vibrations that are happening within the motor. You must have heard a number of papers you must have seen NVH analysis, vibration analysis happening across the IEEE spectrum. So these are some of the ways you do all those things. So now, if I come to the third part of the simulation, you have, like I told you, express is over now, designer is over now. The third type is the RT simulation. So in RT, what happens is that you directly take the model that you have created in the express or designer, you can bring it to a third-party software like PSIM or the MATLAB, and you can take the model, you can create your own control simulation there, and you can run the model. So the motor will run co-simulate with the JMAG module. So MATLAB will simulate, JMAG will simulate. So it's called co-simulation. So the input to the RT model will be the finite element model or the mesh data that you have created in your mesh analysis, the current amplitude, the current phase angle, as well as the winding data of the model. So you can do two types of analysis in RT, the LD-LQ model and the spatial harmonic model, and you can obtain these many outputs using RT. You can see the efficiency map, the LD-LQ map, the flux linkage map, etc. So if I go, so this is a little complex thing, I will show you. So once you co-simulate your model with the JMAG motor model with the MATLAB model or the PC circuit model, one of the most interesting phenomena is the efficiency map. So in this spectrum, you can see how your efficiency is varying with respect to the torque and speed. So based upon your requirement, you can fix your operating point anywhere depending upon the efficiency. Suppose if you want to higher efficiency, you can fix your operating point somewhere here, but you should be watchful that if you fix it here, the speed reduces. So if you fix it there, the speed is high. So likewise, you have to take a stand on the operating point that you are going to that is based upon your application. So whatever application you are using, based upon that you have to assess the efficiency map. Okay, so this is, and you have some other results like the torque speed characteristics, the LD-LQ curve. Similarly, you can see how iron loss is varying with respect to speed and current, how the back EMF is varying. So all these parameters you can do while co-simulating your model with the proper converter model. So this is one particular simulation that we did for the JMAG RT model using the MATLAB simulation tool. So you have some control functions here, and this is the RT model of the motor. And you can either see the outputs in the MATLAB or JMAG window. You can see outputs like the speed versus time, the current versus time, the torque versus time, etc. So this is about the JMAG RT model. Okay, so this gives you an entire picture or introduction of the JMAG window. I know this is kind of fast and kind of not much interactive, or there's no hands-on available now, because this model or this module called the JMAG takes time for you to understand. You have to relate yourself to finite element analysis. First, you have to understand what is happening within finite element analysis. Then you have to understand design phenomenon. So once you understand design phenomenon, then you have to understand about the mechanical parts of the motor. You have to do a good understanding on the mechanical part, followed by the control part. So if you club the FEA simulation into one, you can see that FEA requires good electrical knowledge, good mechanical knowledge, as well as good control perspectives. So if you can have all these things together, you can become a good FEA engineer or a FEA designer. So telling that, these are some of our customers within India and global. There are many more, so I have put only a few here. And if you see, so finally, like I told you, what are the benefits of using a FEA simulations tool for your application purpose? The one is that you can reduce your time that is you are using in design and development. So suppose you have a design that is already existing, you can always do a comparison. Like you can take that design, you can analyze that model, and you can see what is the torque, efficiency, etc., or the parameters you are looking forward to, and based on that you can set your design. So that is helpful in reducing the design time. reducing the number of prototypes. Like I told you, if you are not using a simulation, if you are creating an analytic model and you are directly going for fabrication, chances are that your model might fail to work. I have seen that practically, but when you use a simulation tool, the chances of failure is less. So you can easily understand where your motor is lagging. So you can rework on that model, you can optimize that model, and you can come up with a good model. And this is the third one, the elimination of the trial and error process of development. The machine performance can be observed in details, and analysis of different losses are available. So likewise, machine performance in your lab, you might not be able to do all the performance tests that you can do in a motor, but if you have the motor details, you can do a complete performance analysis in the simulation tool. So that is another important feature that is there in the simulation FEA tool. Likewise, you can analyze the different losses with an accuracy of around 95 to 100%. You can do that. And likewise, last one I told you, optimization is available for the efficiency improvement. So this is about the introduction to the JMAG model. So I hope I have taken much time. I think I have taken almost 50 minutes, because this is how it goes. Even if you go slow, it will take more time. It has to be practiced like a 5-day or 2 weeks workshop. Only then you will be able to understand at least a few things, few of the concepts, and you have to work on that. You have to do yourself. Only then you will understand much about this JMAG FEA tool. So for the time being, thanks. I think that at least you were able to understand that there are 3 modules that are available within the Express Designer and the RT model. Mr. Joseph, he will be introducing you to the GUI. So he will give you a brief about how the Express Windows looks like, how to simulate a model, and how you take it to the FEA, and how you perform the FEA analysis. So thank you all. Thank you for your time and patience. So I will switch over to Mr. Joseph, and he will be presenting you for your next 50 or 1 hour or so. Okay.
Thank you, sir. Thank you very much.
You're welcome. Yeah. Joseph?
Yeah. Hope you can hear me. Right?
Yeah, I can hear you. You can start your presentation.
Okay. So, good morning, one and all. This is Joseph from JMAG team. Hope I am audible. So, as Sadeep explained already, we have many fields in which JMAG can be applied. So, these are the application catalogs. Like we can apply JMAG software for any kind of applications like IPM, magnet, busbar, SPM. So, anywhere when we are using electromagnetics, there we can use JMAG. So, these are the application areas in which JMAG is preferred. So you can see till transformer, you can see the application areas. So so many of you asked for JMAG Express online version. So I am just introducing that. So here, so you can click on jmag-international.com. So this is our website for applying for a free version of JMAG software. So in the products tab, you can see JMAG Express online free software. So just click on that. So you need to give the details for JMAG, details of your personal profile in create account option. So click on create account option. So you need to fill your application, and your application will be processed, and after that you will be getting a user ID and password for entering into the website and using the Express freeware. So please note that you need to register your email ID with institution domain. So this will be the interface of JMAG Express Online. So here you can work on any kind of these motors. This is a freeware. Okay, so without wasting your time, we can go through the basics of JMAG Express, which Sadeep already explained in the previous session. So in the start menu, you can see JMAG Designer. JMAG Designer 19.0 is the latest version we are using. So here you can see JMAG Express. So Under this JMAG Designer 19.0 version, you can see many packages. So it includes JMAG Express, JMAG Designer, Explorer, RT, Job Scheduler. So many options are there. So I'm clicking on JMAG Express now. So you can see a dialog box opened, and you can see JMAG Express for rotating machines. So as Sadeep already explained, JMAG Express is only for rotating machines. So this is not an FEA tool. This is just for a calculation or analytical based calculations can be used in Express to work on your models. So this is for pre-processing of your model. So here you can see these are the which is supported in JMAG Express. So the first one is interior permanent magnet motor. Second one is surface mounted permanent magnet type. So then outer rotor configuration for IPM. Then outer rotor configuration for SPM, three-phase induction motor, single-phase induction motor, switched reactance motor, brush motor, universal motor, externally excited synchronous machine, wound field AC synchronous machine, and clock pull alternator. So these are the machines which is supported in JMAG Express, the analytical tool. So without wasting our time, we can roughly go through the configuration of JMAG brushless motor SPM configuration. So I'm clicking on that. So here you can see this is the first window which we can see when you are clicking on brushless motor SPM. So here we have three options. The first one is build new combination option. The second one is import DXF file. So if you already have your CAD file with you, you can directly import that file into JMAG Express by clicking on this option. And third one is without giving the permissions for selecting the stator and rotor separately, they have given the options for selecting the entire combination of stator and rotor pole geometry. So here you can see three different options. So as of now, I'm clicking on build new combination option. So when I am clicking on build new combination option, you can see different types of stator and rotor available within the rotor templates of JMAG Express. So here you can see according to the specification of magnets and rotor core, you can see ring magnet, constant angle, constant width, constant spacing, constant width with semicircular, constant width decay. Like that, you can see different types of rotor templates available in our library. And similar to that, you can see the stator templates like parallel tooth opening, arc bottom, slot angle. Like you can see many varieties of stator templates here. So this is how we can see the templates. So I am selecting any of the combination from rotor and as well as from stator. So I'm clicking on the ring magnet combination for rotor, and for stator I am clicking on parallel tooth opening. So when I am clicking, the model will be loaded within this window. So here you can see this is how we can see the model in JMAG Express window. So as you can see in the screen, this green shade is stator part, and these pink parts are the windings part, and you can see the ring magnet which is on the surface of a rotor core, and in the blue color you can see the shaft. So this is how we can see the model here. So coming to the options which is available in Express, you can see in the requirement tab you can enter the details which is into your model. So here you can mention your rated power in kilowatt. So if you know all these details, you can fill these details. The maximum torque, rated revolution speed, maximum revolution speeds, all these details you can input in the requirement tab. So probably this will be your outputs which you are expecting from your motor model. And number of holes, number of slots, the details which is already available with you that you can input here. So coming to the dimensions window, if you want to change the dimensions of your model, you can click on the diameter or the parameters option here. So whenever I am clicking on this parameters, you can see a dimensions line will be showing the parameter which you have specified in the dimensions tab. So here you can see for each and every dimensions are specifically shown by the dimension lines. So if you are not familiar with the terminologies which is used in dimensions tab also, you can identify with the dimensions lines. So this is how we can see and visualize all these things. So it will be really good if you can visualize these motor models when you are taking any lessons or classes in colleges. So this is how we can see the details. So you can change any of the details according to your design. If you want to change any of the parameter, you can change that. Say for example, if I am going to change the gap length means the air gap length, you can change that like this. So according to your inputs, it will change any of the details. Like if you want to change the outer diameter, say for example 195, you can change that. So you can the difference when you are changing the parameters. I'm getting you some noise. Possible to please mute your mic. Okay, thank you. So you can see materials tab. So this is a tab which we are mentioning materials for stator core and rotor stator coil and also for the shaft. So here you can see the parts. You can see stator core and coil. So when I'm clicking on the stator core, you can see the category. So these are the manufacturers basically. So these many manufacturers are available for the steel core, which is available here. So here you can see we are already having many manufacturers here. Upright, ArcelorMittal, China Steel, Hitachi Metals, JFE Steel, which is default in our express window, and Mitsubishi Steel, Nippon Steel, Sumitomo. Like that, we have many manufacturers here. So like that, you can mention any of the manufacturers from the list. So as of now, I am selecting JFE Steel, JNA Core. And in the product tab, you can see the variation of the steel. So you can see 35JN210. So this is the gradient of the steel with 0.35 mm lamination. Similarly, if you are selecting 50JN230, this is a steel variant for 0.5 mm thickness lamination. So similar to this, you can see in any of the manufacturers, you can see the product variations like this. So this is a way in which you can mention the category of steels and gradient. So say for an example, if you don't have your steel in your list, you can click on the custom steel option. So there you can define your own particular material. So if you don't have your material property with you for a particular manufacturer, you can design your own custom steel here. So for an example, I am giving the values like 0, 0. So here you need to enter the values for B and H values. So here you can see minimum 3 points should be specified in order to mention the B value. So here you can see I have given 50,000 RPM per meter for 1 Tesla, 20,000 1.5 Tesla, 25,000 2 Tesla. Like that you can mention the BH curve and also the coefficients for hysteresis and eddy current, and also the mechanical properties like density. You need to fill these details in order to Okay, thank you. So here you can see how we can fill all the details like this. So after that, you can click on OK button. So your steel will be your custom steel will be shown here in terms of magnetic flux density and magnetic field in this particular graph. So, and if you want to change any factor, like if you want to change the ion loss for a particular with a particular Jaggarajupeta factor, you can give this here. So this is how we can mention your custom-made steel here. So in the coil, you can see by default it will be having copper and aluminium. And if you want to change the material other than this copper or aluminium, you can mention other, and you can mention the electric conductivity and density for the particular material. And similarly for rotor, you can see the rotor magnet and rotor core and shaft will be there. So for rotor magnet, similar to that which I have explained for stator core, you can see the type of manufacturers or category here. So these are the manufacturer which is available in the templates. And here also you can mention your magnet with custom magnet option. And here you can see NDFEB magnet combination for 1 Tesla, 1.2 Tesla, and 1.4 Tesla variation. So similar to that, you can change your magnetization pattern here. So here we have 3 options. One is parallel. So when I'm selecting the radial option, you can see the variation of magnetic flux or magnetic orientation for this particular rotor magnet. So when I'm clicking on polar anisotropy, your entire magnetization pattern will change accordingly. So here you can mention the radius also if you want to change. So as of now, I am clicking on parallel only. So if you are having some temperature correction factors, like if your magnet is operating at a particular temperature, you can mention it here. And if you want to correct the correction with a correction factor, you can mention it here per percentage per degree Celsius. So in the third tab, hope Sadeep already explained all these connection methods and resistance tabs here. So here you can see in the connection method, you can see whether it is a star or delta connected motor. And in the parallel number, this is like, so when I'm clicking on the next tab for motor diagram, here you can see when I'm selecting number of parallel number equal to 2, you can see 2 sets are connected in parallel. Similarly, when I'm changing it to 1, you can see these are connected in a serial fashion. So when it is connected in star fashion, you can see the end of U, V, and W phases are connected in a common neutral point. Or if you are changing it into delta, you can see the end of U phase winding is connected to the start of V phase winding, and end of V phase winding is connected to the start of W phase winding. So this is how we can change the connection method. So here you can see if you are already having your details for phase resistance, number of turns, wire diameter, film thickness, all these parameters can be mentioned by changing the input item. So if you only having this phase resistance, you can mention the number of turns and phase resistance like this. So for an example, if I want to change it to 0.48, I can change like this. So this is how we can change this. And if you already having other details, you can click on input item. There, if I am changing turns per wire size, you can fill all other details like film thickness, number of strands, slot factor, like that. You can mention all the details. So as of now, I am going with these details. So here in the number of layers, if I am selecting 1, it's a single layer. And if it is like 2, you can see the other layers of coils which is connected. So in the winding configuration, you can see 3 options. The first one is automatic, and the second one is automatic concentrated winding, and third one is manual. So the first option, automatic, means it is a distributed winding. So when I'm clicking on this distributed winding, you can see the coil which is by default it is 1, 2, or 3. You can change this accordingly. So according to that, your winding pattern will also change in the motor diagram. So if I am changing it to 3, you can see more windings will be connected. So similar to that, if you want, you can change it into concentrated winding. So by default, it will be selected as 1 for coil pitch. And if you want to change the design according to your particular motor, you can give the manual path like 1, 5, like that. You can give your own design. So you can see the wire, the coil will be connected from the first slot to the 5th slot. Like that, you can design your own winding also. So this is how we can design your winding. So in that, coming to that 5th tab, you can see in the drive tab. So in Express, since it is based on analytical calculations and numerical informations, here we don't have any options for circuit editing. So here we can give the voltage source or current source or voltage 120 degree source. So these are the 3 options for voltage or current sources. So as of now, I am selecting current source if it is a current control device. And here you can mention the amps which is specified for your particular motor. And if you have any current phase degree, phase angle, you can mention that. And this will be my rated speed, so you can mention that. So this x-axis is so if you are mentioning this revolution speed, your plots will be generated according to the revolution speed. So if I am changing it into line current, your entire plots will be generated based upon the line current. So as of now I am changing it into revolution speed for better understanding. So here you can see I have entered all the details. So we are just roughly giving some values, it may not be correct. So after entering all these details, so one more thing, actually this is the motor diagram, this is the winding diagram which I have explained already, and this is a slot diagram. So if you want to see your slot diagram, you can click on U phase, E phase, W phase according to your design. So if you want to see only the U phase, you can see the pattern of connection here. So U dash. So similarly, you can see P and W phases. And in the characteristics window, you can see the value which you have entered in the dimensions tab. You can see it in the table. So now next we are going to evaluate our model according to your design. So you can click on evaluate button. This button is the evaluate button. So by clicking on this evaluate button, you can see the plots characteristics will be generated according to your particular design. So this is the curves which we are getting after the calculation in JMAG Express. So here you can see the torque versus revolution speed. So this is what I have explained. So instead of giving it into revolution speed in the x-axis, you can change it into line current or current pace. So according to that, your plots will be changed. So here you can see that the machine is giving a constant torque of about 4.6 or 4.75, and here you can see the efficiency is increasing at a particular point of 2000 rpm into 80%. So here you can see we have given this orange color defines the input which we have given in the requirement tab. So here you can see we have provided rated power as 1 kilowatt, so that's why it is coming into the orange color. So here you can see whether your motor is reaching the desired power or not. So at a particular speed of 2000 rpm, your motor is approximately reaching 1 kilowatt, and you can see the copper loss graph with respect to speed, iron loss, line voltage, and power factor is start dipping at a particular speed of 2000 rpm. So similarly, you can see all these details like this. So the same details you can see here in the characteristics tab also. Here you can see self-inductance, mutual inductance, motor torque constant, KT, K value, average teeth flux density value. So all these details will be shown in this particular tab. So here you can see all the results. So say for an example, if I want to change, or if you want to compare the results of two motors that with different dimensions, that is also possible by changing the parameters. So say for an example, if I am changing the gap length, so as of now I have given around 0.195. So if I want to change this, so here you can see some yellow colored inputs here. So if I want to change this into 3 different values, say for an example, if I am changing my air gap into 0.5, 0.8, we can mention it in a tabular form. So after inputting all these things, you can click on this parametric evaluation button. So here you can see a gear button here. So just click on that. So here you can see when you are changing the value into 0.5, here you can see your torque is reduced, and related to this you can see the results. So here you can compare these two graphs for different air gap, which is mentioned in a green and blue color. So this is how we can compare the results for two machines with or a single machine with two different parameters. So this is how we can see the results. So similar to this, you can change any of the parameters in terms of stack height or number of slots. So similar to that, you can change any of the parameters and you can click on parametric mode in order to evaluate your motor for different parameters. So this is all about JMAG Express. So similar to that, you can if you want to edit your template, say for an example, if you want to edit your template with existing templates in the designer, sorry, in the Express, you can click on any of the other templates in order to change your templates, stator templates. So, and one more thing, if you want to, again, if you want to change the stator geometry, you can click on edit current template. So here you can see only one slot will be visible here. So this one slot will be circularly patterned around a particular point, that point. So we need not design the entire geometry. So only thing is we need to create a one slot model for stator and one pole model for rotor. So here you can see you can click on edit in JMAG designer. So it will create a link between JMAG Express and JMAG. So here you can by right clicking on edit sketch, you can edit this particular design of teeth or slot. So here you can see. So after once it is done, you can click on edit, get from JMAG designer. So the model which you have edited or modified there will be shown here. So here you can see you need to, once it is imported into JMAG Express, you can define what are all the parts which is coming under stator core. So here region 2, region 3. So these are the two regions which is available. So you can specifically mention the stator core and coil here. So here you can see two coils parts will be selected. So once it is done, you can click on back button in order to create your own model. So if it is your own model, you can click on OK. So it is registered as a default model. So this is how we can go in depth to the design of particular motor with JMAG Express. So coming to the JMAG RT module. So Sadeep already explained about JMAG RT module for co-simulation between MATLAB or Simulink or PSIM. So here you can see if you want to click on, if you want to create an output file, you can create a model by clicking on the model. So it will, clicking on copy files for simulator, it will create files for PSIM or Simulink. So if I am clicking on Simulink, it will create a file for PC. And if I am clicking on electrical signal input Simulink file, it will automatically create a file for Simulink. So here you can see I can mention the file type. So here you can see file name I can specify. So this file will be generated as a RTT file, .rtt file format, and parallelly it will create a file for Simulink also. So you can create a Simulink model for your motor model, and you can work on that. So this is how we can create JMAG RT model. So as of now, I'm not going to that. So coming to the export option here. So here you can see the files as CSV files, which is compatible to any spreadsheet software, and the second one is for PDF file. So here you can see the output file can be generated in terms of PDF file. So here you can see the graphs will be saved as PDF file. So here you can see the graphs which I have created. Values will be broken like this. So coming to the machine other parameters that also will be there. So this is how we can export our results files. And coming to the digital format file, like the CSV file, you can export the evaluation results by clicking on this particular tab, particular icon. So here I'm saving the file for CSV in CSV format. So when I'm opening that, you can see all the values are in a numerical format. So here you can see the values which we have entered, and values taken automatically by Express will be shown here. So this is a part which Sandeep already explained. So if you are going for your particular procurement stage, you can see here. So the mass properties will be specifically mentioned here. So these are calculated by the Express itself. So the total volume for stator, core, coil, and rotor, and densities, everything will be mentioned in the mass property window. And coming to the graphs window, you can see the graphs which I have plotted there will be shown here in the digital format. So using this CSV file, you can create your own maps for different machines with different parameters. So you can plot a graph with this x-axis and y-axis. So this is how we can see the results in CSV file. So for all the graphs, you can see the results. So this is our Express. And coming to the designer. So designer is the FEA tool for detailed analysis of your particular model. So there you can discretize your entire model into triangular or tetrahedral. For each component, we will be having different machine, and we will be analyzing it in the tool. So here you can see a button called calculate it in designer. So when I am clicking on calculate in designer, it will create a link between JMAG Express and JMAG designer. So it will ease our operations of creating a model in JMAG designer. So here you can see 2D, 3D. So when I'm clicking on this link, it will ask whether you want to create a 2D model or 3D model, and whether you want to create a partial model or full model. So in order to save time, you can click on partial model. So it will reduce the time. So because we are creating a mesh for only the quarter part or half part, so that's why we can reduce the simulation time. So I am clicking on the full model. The full model will be imported into designer, and it will start automatically simulated. So here you can see, and I'm clicking. So for the ease of understanding, I'm clicking on full model. So I'm clicking on full model. Okay. So here you can see the model automatically loaded into JMAG designer window, the software or the module which is used for FE analysis. So the model is loading now. So it will take some time in order to load the model. So here you can see the model starts running. So the model now imported into designer window. So here you can see all the details that we have mentioned there will be replicated here also. Here you can see stator core. So here for in-depth analysis, we can use JMAG designer. So here you can see stator core, coil, rotor magnets, rotor core, shaft. So what are the parts which are coming under assembly part? You can click on that, and it will be shown in the red mark portion. So coming to the sets, so these are the sets which is created for ease of assigning some conditions, which I explained. So the part. So here you can see system audible. Go. Yeah. Okay. So coming to the study, you can see these are the studies which is available in JMAG designer. So when I'm clicking on new study, you can see here the magnetic study in static analysis form, and with respect to time you can analyze your model, and with respect to change in frequency or in frequency domain also you can analyze your model. With respect to axis symmetry, you can click on static, transient or frequency. And again, in the previous presentation, Sadeep already explained about structural analysis. So these are the analysis which is available in structural mode. And apart from this, we can have thermal analysis also for your model. So once we are creating or importing the model from Express to Designer, all this study and parts conditions will be assigned automatically. Or if you are creating your own model in the default CAD editor of JMAG Designer, so here you can see JMAG window in like this. You need to assign all the conditions and you need to create parts and you need to define the materials. So here you can see the material which I have mentioned there will be shown here. So say for an example, if I am going to select any particular material for stator core, you can click on the material here, and if it is JFE steel, so this is in the left side you can see the project manager window, and in the right side you can see the toolbox. So here in the toolbox, when I am selecting in the material tab, when I am typing JFE, you can see JFE steels. So if you have created your own model separately in JMAG CAD editor window, you need to assign all these materials connections, and you need to assemble the parts and everything by yourself. Otherwise, you can create your model in JMAG Express and you can import it into Designer. So every conditions and everything will come automatically. So this is how you can create. So if you want to change any of the material, so I am duplicating the study. So here you can see the study which I have duplicated. So coming to the materials, so if I am creating my own model in Designer CAD editor, you need to define all these parts. So this part should be created or defined properly, and after that you need to assign the material like this. So if 35JN2110 is the material which you are using for your model, you can simply drag and drop that material into your stator code. So here you can see whether it's a laminated one or normal one. You can change that, the lamination factor and all other things, and you can allow eddy current or not allow eddy current. So here you can mention the conductivity and all other things in this particular material. So this is how we can assign the material. Similarly, you can assign material for core also. So if I am selecting the material for core, I can give the material like this. So similar to that, you can mention NDFEB magnet. So when I am clicking on NDFEB, you can see bonded NDFEB, sintered NDFEB, hot processed NDFEB. So you can select any of the material for magnet, like irreversible or reversible like that. You can directly drag and drop it into the particular material. So here it will ask for the magnetization pattern. Here these many options are there for magnetic patterns. If you want to change the patterns, you can click on like that, you can change. So once everything is done, you can and coming to the circuit, which Sadeep already explained, once the assigned material assignment is completed, you can create a circuit for this. So here you can see add circuit. So since I have duplicated the study, you can click on edit circuit. So this is the default circuit editor window for JMAG Designer. So these many options are there. The generalized switches, components, and ground points, voltage probes. So everything is available here according to your designs. So if it is a brushed motor, you can see brush or commutator, and you can see the coils. So everything will be visible here. So you can simply click on that in order to place it there here. So if it is a voltage source, you can click on voltage source. And when I am clicking on voltage source, you can see with respect to which axis you want to have the supply voltage. So here I have selected time. So here you can change whether it's UD, UWV or UVW. You can change the phase order, and in the amplitude you can give the value. Like say for an example, if it is a 380 volt peak volt machine, you can give 380 volt. But you can see you can mention like say for an example, if it is a 60 or 50 hertz, you can click on 60 hertz, and the phase angle also you can mention here. So similarly, you can create each and every block. So here by default I have selected and I have imported my model from JMAG Express. So circuit is automatically created within a few steps. So here similar to the voltage source, I can see UD, UWV and UVW phase order. If I want to change, I can change. And in the star connection, I can see the coil for U, V and W. So here you can again edit your model. Like if it is more than 6.49 ohm, you can change that. And if you are considering the leakage inductance, you can mention that. So this is how we can change phase resistance of coil in the circuit editor. And similar to that, we have many other options for different division, and we have sinusoidal option, cosine option, and like that we have many options. And we have switches, branches, steps, ramp. We have many functions for generating your desired circuit. So, and if you want to particularly design your circuit for any particular switches like IGBT or MOSFET, you can create a model using the Simulink option, which I have explained already, and you can input it into MATLAB window. So this is how we can create circuit. And coming back to the model, once the circuit is edited and defined properly, you can create some conditions. Like here you can see the conditions. You need to define whether it's, the coils are connected in a particular fashion, which is specifically for your particular model. So here you can see, when I am zooming, you can see the dot connection and cross connection. So I need to define in the geometric window, I need to define what are all the parts which is coming under the coil and what are all the parts coming under the motion condition. So here you can see the conditions in the toolbox. So here you can see the FEM coil. So you need to drag and drop this FEM coil into the coils which is coming under the conditions. So here you can see I'm drag and dropping it into this coil portion. So here it is automatically created. So this is a part where we are linking these geometric coils with our circuit coils. As I have already explained, here you can see coil 1, coil 2 and coil 3. So similarly, that coils will be linked to these geometric coils in this linking part or linking condition like FEM coil. So here I can link the coils, and I can specify the parts which is coming under the U phase coils. So these are the parts which is coming under the U phase coils, and I can mention whether it is upward or downward. So here if I am changing upward, you can see this direction is changing it to dot or cross according to my input. So as of now I'm not changing that. Similarly, you need to define for U, V, W. So the parts coming under V and parts coming under W should be properly specified. So once it is done, you can drag and drop this condition for motion into this. So here you can see under the torque condition and motion condition. So here in the motion condition, you can see rotational, translation and collision motion. So in translation motion for linear motor, you can use translation motion. And since it is a rotating machine, you can click on rotation and you can simply drag and drop this into the parts which is coming rotation. So here you can see I have applied it in the rotor magnet. Similar to that, I need to select magnet. So when I'm clicking on that, the list is appended with rotor core and shaft. So these parts should be properly specified. So, and once it is done, you can mention your rated speed like 2000 RPM here. So this is how we can mention the displacement type and other functions here. So if you want to mention point sequence for your motor, like within this time, it is, if it is rotating at a particular speed, you can give point sequence for your motion. And similarly, if you want to define your motion using an equation, you can click on equation of motion, and here you can see the torque equation as you have already seen in your control system note. So here you can see the load torque can be mentioned, moment of inertia, and all other details can be mentioned properly for better understanding if you already know all these coefficients. So as of now, I am clicking on constant revolution. And say for an example, if you want to see some fault analysis of motor, you can click on eccentricity condition. And if your rotor is tilted with respect to your mean position of the rotor, you can mention or you can study the effect of eccentricity of your particular motor. So here you can see the tilt angle, rotational angle, center of tilt, all the details and offset from the mean position that you can mention here. So this is how we can use all these conditions, and upward or downward means whether it is rotating it in the clockwise or counterclockwise direction. And this is the point with respect to which we are rotating our motor. So this is how we can create a motion condition. And similarly, we need to define our torque condition. If you want to analyze the torque which is coming out of our motor, you need to directly apply the nodal force condition to the rotating parts which is coming under this. So here you can see already the motion, they have created a set in order to accommodate all these three things. So it is coming under motion region, a set. So this is how we can create the condition. So once it is done, you will move to the meshing part. So here you can see the meshing is automatically done since I have already created a mesh. So here you can see our aim is to maximize the air gap flux density in order to maximize torque or power. So in that particular area, you can see the fine meshing or more number of meshing. So other than that, the meshing size will reduce. So this is how we can create the meshing of our particular motor. And coming to the specific meshing. So if you want to check the properties, you can see the slide mesh option, standard meshing option, and generate mesh option for each step. So here, this is our model length. So compared to the actual dimensions of machine, we will be going through, we will be considering some outside area also. You can see when I'm clicking on mesh region outside the boundary, you can see the pink colored area. So this area are also considered for considering the leakage flux of your particular machine. So if you want to reduce that, you can reduce it in the properties window. So this is how we can change the model length. So this is a model length multiplier. So if it is reduced, a minimum area will be calculated to consider properties. So here you can see it is set automatically. And if you want to change the dimensions like the default element size for machine, like 1 mm or 2 mm, you can change that. And this is the option for setting the radial divisions or circumferential divisions of our particular motor. So this is all about meshing. And coming to the results, you can see when I'm clicking on the first results which we have created already, you can see I can create contour plot for all these machines. So here you can see when I'm clicking on the contour plot for flux density. So this is the result type which we can see in the contour plots. So magnetic flux density, field strength, magnetization, current density, everything will be visible in the form of contour plot. So here you can see your machine is having a magnetic flux density up to 1.8 Tesla. So when I'm clicking on this play button, you can see the animation here. So this is how your motor is performing, and how the hotspots are created according to your designs will be visible using this express designer window. So here you can see the maximum value is switching between the tails. So you can see up to 1.8 Tesla is getting the value. So this is how we can create your own model, and you can visualize all these things. So, and if you want to see the results in vector form, you can click on results. You can create, right click on the new vector plot option. So if it is for magnetic flux density, you can click on apply and OK. So this is how your flux density vectors are flowing. So when I'm again click on the animate button, you can see where the maximum flux vectors are flowing and where the hotspots are created in the maximum point. So here you can see the flux density plot and vector plot separately. So this is how we can see your model. And again, if you want to see the results for flux lines, again you can click on right click on results, click on result flux lines. So if you want to create for magnetic flux density, this is your flux line plot. So again you can animate this. So this is how your flux lines will be generated and flowing through the teeth. So by visually explaining all these things will be more convenient for the students and also for the staffs in order to explain all these things. So this is how we can visualize all these things. And other than that, when you are clicking on the graphs tab under the result option, you can click on torque option in order to see your value. So here you can see since we don't have any options for minimizing your torque ripples, it's varying in between these values. So and you can see the average value will be around 4.42. You can see the dashed line. So you are getting some torque ripples, high amount of torque ripples here, like this. So similar to that, you can see your graphs for any other parameters like circuit current, circuit power. All the details will be visible like this. So this is how we can see all the graphs. So if you want to see the coil inductance value, you can see this. So all the values will be visible using the graph option. And if you want to see the results and if you want to export the results, you can export the results in the form of CSV file. So here you can see export all cases. So here you can see you can save the values in CSV file or text file. So this is how we can change that, or you can save that. And again, if you want to have parameterization here, you can right click on the parameter here. And if you want to, say for an example, if you want to change your speed and with respect to speed, you are going to analyze, you can click on show cases here. So here you can see, I can change my speed like this. So similar to that, I can create case. So as of now, you can see only one case here. So when I'm creating multiple cases for multiple speed, you can see here 4 cases will be generated here. So this is how we can create cases. So now 4 cases are generated here. So for each case, you can run the analysis in order to have the results. So this is how we can see the JMAG designer window. And again, in the help manual, you can see self-learning system. So here in the practice mode, we are having many studies like for 2D and 3D, structural, thermal, and all the analysis. So here you can see the stepwise analysis for creating from the scratch to up to the results. You can see the steps. So it will explain clearly how we can create a motor model in the self-learning system. So this is how we can utilize everything. So apart from that, we have optimization option and topology optimization in order to see the results. So this is all about JMAG designer. And one more thing you can see the JMAG RT. So here you can see the JMAG RT module. So here we have the option in order to create the model for. Actually, I have explained one option to create. I have explained already in order to create an RT module for Simulink here like this. Or for BC also you can create the model here like this. And similar to that, you from the design create this RT file using this particular option, JMAG RT Library Manager. So here you can create a new model. So these are the motors which is supported For co-simulation environment, you can see three-phase permanent magnet synchronous motor, stepping motor, solenoids, synchronous motor. So, and you can click on generic model if it is a general model. So you can click on OK button. So here it will ask whether you want to create LD, LQ model or special harmonic model, and you can mention the file which is created from JMAG designer. So in the study, you can click on JMAG, click on export option, export JCF. So this entire geometry data or mesh data can be exported into the other module called JMAG RT. So here, JCF file will be selected for creating the simulating file. So this is how we can create our own model in JMAG. Yeah, so here you can see I'm creating a model for three-phase permanent magnet synchronous motor. So by clicking select is specifically mentioning the folder or file which is created in the JCF. So here you can see. I'm exporting the mesh data here. Or geometry data is also fine. So here you can see the SPM file. So I can select that. If I'm clicking on LDLQ model, I can click on OK in order to enter all the details. So here you can mention the details for permanent magnetic synchronous motor. So here you can mention the values, and here in the advanced settings, you can mention the point sequence for current, like 1.5, 1, 2.5, 3.5. Like that, you can mention the current values, and you can mention the phase angle values. Like if it is there, you can mention like 5 degree, 10 degree, 15 degree. So like that, you can click on advanced settings, and you can export your and you can create your own model for RTT, and you can simulate it in the co-simulation environment for MATLAB simulink. So in the practice mode, you can see when I am clicking on control circuit simulation for JMAG RT, you can see the procedure for creating all these things. So here you can, by using the RTT file, you can generate these many graphs. Like you can create these steps, and you can input all these details. You can see the circuits for that, and you can visualize the current and torque value like this. So this is how we can, or this is for the time sake I'm explaining it using this thing. So similar to this, you can place or replace your permanent magnet synchronous motor from your menu, and you can create this JMAG RT PMSM module you created using JMAG RT, and you can replace this the module for PMSM with this RTT module. So this is how we can create our own model, and you can compare the results. So this is how we can. So this is all about JMAG designer. JMAG designer. So for detailed analysis, some other detailed analysis are also there for 3D, and also for structural, and also for thermal analysis. So as of now, the time is so limited, so I'm stopping with this. So hope you understood at least some points for FE analysis for using JMAG designer. So for further inquiries, you can type your email ID and you can mail us any queries regarding the use of JMAG FEA software. So thank you for attending this webinar. Thank you.
Thank you, Joseph sir and Shadeep sir. Thank you for your overwhelming explanation of all the machine designing parameters. So thank you very much, sir. Thank you, sir.
Yeah,
Participants, please fill your feedback so that we can just track out what are your problems, what are the positives and negatives of the STC. Thank you very much. Form is in the chat box. Please fill it.
Yes, sir. Dear participants, any doubts, please mail to the listener, sir. Sir.
Me, sir. So shall we close the session, sir?
Yeah.
Participants, do you have any doubts?
Sir, participants,
Please
if you have
raise your
any doubts,
doubts.
please.
Hello. Hello, sir.
Yes, ma'am. Yes.
I have a doubt into benefits of a JMAG.
Okay.
It is used for optimization of efficiency performance, but for accuracy,
Yes.
efficiency, we have to calculate all types of losses. But what about the mechanical losses, but frictional losses and windage losses?
Yeah, that also can be. You can see in the motion condition. You can see some of the options for low torque. So here you can, with the equation of motion, you can mention your low torque, and some of the mechanical losses can be calculated using this.
Okay, sir.
Not all the losses, but some of the losses can be calculated. The friction and windage losses may not be calculated here.
But we have to use for JMAG is for better efficiency.
Yeah,
so
when it is compared, yeah, when it is actually here we don't have any option for coupling. So here the entire motor is, or motor model is assumed for this analysis, right? So here you can see the results for internally without any mechanical coupling or something like that.
Okay. So what are the benefits of JMAG?
Yes, ma'am. Can you repeat once again? Your voice is breaking.
We are neglecting the mechanical losses, so it is the disadvantage of the JMAG.
No, actually we are not neglecting some losses in efficiency mapping. Efficiency mapping is separate with respect to that LD LQ map. So there we are not considering that. But here in JMAG Designer we can input all those details using the equation of motion. So efficiency mapping is separate compared to this thing. So it's a separate module. So hope you can see my screen. So here. So you can see my screen. Hello.
No, sir.
Yeah, so here there is an option for efficiency mapping. So this is using a module called JMAG RT viewer. So here we are not considering the mechanical losses.
Okay.
So other than that, in
Thank you.
JMAG designer we can consider the mechanical losses. Yeah. Yes.
Thank you, sir.
Yeah. Thank you.
Participants, any more doubts? You can just ask Joseph, sir. So, Joseph, sir, a query, sir, from my side.
Yeah.
Sir, what should be
Okay.
the specifications of the PC or a laptop to run a JMAG software? Any
We
special?
recommend, yeah, we recommend minimum 8 GB RAM and i5 processor. So more than that is also fine. So minimum 8 GB RAM and i5 processor should be
Okay,
fine.
thank you, sir. Thank you, sir. Thank you, sir.
Good afternoon, Joseph, sir.
Yes, sir. Please.
Sir, can we compare this analysis with model analysis?
In which parameters, sir?
It is for boundary statistics.
For mechanical analysis, you are saying, or for any other?
That is, sir, that is includes scatter end winding.
Okay.
In that part, we have done the model analysis to determine the losses of the scatter slots.
Okay.
Can we implement that part in terms of numerical analysis?
That also possible. Actually, here we have option for scripting and other things. So you
Okay,
can
sir.
simply input those details in scripts in order to create your model.
Okay, sir.
Okay. So that is one option. And geometrically, instead of here, I have, hope you can see my screen. So here, these are all numerical informations. So you need not draw your own model. You can simply type your details like in the numerical form.
Yes, sir.
Okay. Yeah. Okay.
So we can compare with the model analysis.
Yes, we can compare that.
Actually, we have done one module regarding the model analysis with COCO 80X and hammer test.
Okay.
And with accelerometer. I think you got this.
Okay. So your specific application, please, could you please send me the mail, sir, so that we can go into that. And
okay, sir.
I can go through your query in a separate mail. So I can
okay,
go
sir,
through
okay.
your query and I will get back to you, sure, sir.
Okay, sir. Thank you, sir.
Thank you.
Thank you, Sridham, sir. Joseph, sir, can you just put your slide off with respect to your mail IDs and phone numbers, sir, so that will be useful for us. Any slide regarding your numbers and phone mail IDs.
Hope I have shared my mail ID. Just a second, I will.
Sir, at the time of installation, which country we select, sir?
Hello.
Sir.
Hello. Yeah, I can hear you, sir. Please.
Yes, sir. At the time of installation, which country we should select for installation purpose?
Others. Yeah. Oh, yeah. That you can select other. Other option will be there.
Other option.
In the down part. Yeah.
Okay, sir.
So that is not for installation. Actually, registration should be there. So you need to register in your institution domain, and later they will provide you the user access in order to access all those details. Hope you can see my screen. You can note down my and also Sadeep's mail IDs.
Sure, sir. Thank you.
Okay, shall we end up the session, sir?
Participants, anyone having doubts? Okay, sir. Close it.
Okay, thank you.